Hi folks, Howard here. Welcome to Complexity Unraveled. If this is your first time on this channel, we cover a wide range of topics from technology, megatrends, business venture, to macroeconomics and social issues. To put it differently, we are interested in topics that are complex in nature and of great relevance to the society. On this channel, no one will ask you to like, share, or subscribe. So please click on nothing, smash nothing, and buy nothing. If you share our interest in this kind of topics, please give us 15 minutes of your attention and we promise to make it worthwhile. Today is special. We're finally going to cover something that has been on our topic list for so long. Something felt like a must for any tech-centric channel. And you guessed it, 5G and 6G. You know, it was roughly 4 years ago we looked into 5G as a technology and its implication on business and industry for the first time. I can still vividly remember what we concluded from that study. The TLDR version is amazing technology, great potential, but unlikely to have any real impact in the next 2-3 years. Just to be fair, it was a quite long time ago. At the time, the 3GPP 5G Release 15 was not even dropped, and only non-standalone 5G network was available. Core features like ultra-low latency communication, indoor positioning, and network slicing were not supported yet. The only thing it could do was higher data rate and faster transmission, and even that was piggybacked by 4G core network. In the past 4 years, 5G has gone through the entire hype cycle, from highly anticipated by the consumer and industry to today's rather awkward position. You might ask, awkward how? You see, when you hear cynical statement like the speed tester is the only true 5G app, it's quite obvious that 5G has not made its redemption yet. But there's also positive news. With 3GPP dropping 5G Release 17, the system features have finally reached the mature stage. 5G network deployment is making steady progress all over the world, and all major cell phone makers have launched 5G phones aimed at the mass market. Even though 5G penetration is still at an early stage, industry leaders like Huawei and Samsung are already heavily engaged in the 6G research. With the stage finally prepared for 5G to live up to its hype and the green light for the 6G race, we believe it's a good time to revisit this topic, to shed some light on the current state of 5G deployment, and more importantly, to look beyond the age of 5G. If you are interested in specific use cases, we're in the process of doing a separate mini-series. It will cover 5G's impact on almost 20 different business sectors and industries. But for today, we will take a broad approach and share some of our knowledge on 5G and 6G. Since we want to maintain a concise format, we will split this video in 2 parts, with part 1 focusing on the current state of 5G and part 2 on the concept of 6G. To better understand the current state of 5G, let's have a brief look into the history of cellular technology. It's hard to believe that the first mobile phone was demonstrated almost 50 years ago in 1973 by Martin Cooper, who worked at Motorola at the time. Mass commercialization started in 1979 in Japan. Only 5 years later, by 1984, 1G service was already rolled out nationwide. Unlike today's technology, 1G is an analog system without encryption. But being the first generation mobile network, it defined the cellular concept. The launch of 2G in 1991 was the leap into digital age. 2G brought not only better voice quality, but also for the first time, people could send text messages to each other. 3G opened up the door to mobile internet. Even though the data transfer capability is kind of laughable by today's standard, it was the first time video conferencing and voice over IP became possible. The 4th generation, as we know today, sets out the prime time for mobile internet. It offers a peak data rate up to 1 gigabits per second, a truly gigantic performance jump. From mobile multimedia, customized personal service, to global mobility support, app economy, 4G is the backbone of our connected lifestyle. Anytime, anywhere, always connected. As far as we can see, the development of mobile cellular technology has been largely matrix-driven. Over and over again, higher network capability has pushed applications becoming increasingly more sophisticated. 5G is the latest installment within this matrix-driven paradigm, and it's a huge one. Compared with 4G, peak data rate increases tenfold and reaches 10 gigabits per second. 1 millisecond network latency is 100 times less than in a 4G network. The number of devices per square kilometer increases a whopping 1,000 times and reaches 1 million devices. Not to mention the system features like indoor positioning, massive machine-type communication, and network slicing open up the door for novel industrial applications. I mean, sounds great, doesn't it? I'm quite sure you have already heard all this in the past. With 5G, you can download a 4K movie in less than 10 seconds. And there are many other cool things you can do with 5G. Paired with 3D holographic, the SK Telecom in South Korea made a photorealistic dragon flying into a baseball stadium. I mean, that's really cool. It's a damn dragon. How are you gonna top that one? For me, that's the definition of over the top right there. And don't forget gaming. For gamers, lagging becomes a term from the past. It takes human brain at least 20 milliseconds to register a visual signal. With ultra-low latency, 5G gaming becomes an instantaneous experience. So people must be rushing into stores to get a new 5G phone and changing their cell phone plan to embrace this new mobile internet revolution. Well, not exactly. Let's take a closer look at 5G, the good, the bad, and the ugly. It's quite important to have this common understanding before starting our discussion on 6G. Well, let's start with some good things first. Since the world's first commercial 5G network rolled out in 2019, many countries have joined the 5G race. China is clearly leading the pack there, with well over 700 million 5G subscribers and 1.3 million installed base stations, followed by South Korea, with nearly 30% 5G penetration and 20 million subscribers. Considerable progresses are also made outside Asia. In the United States, the number of 5G users has almost doubled in 2021 and reached estimated 40 million. 24 countries have launched their own commercial 5G service in the European Union with combined 30 million users. According to Ericsson, by 2027, in just about 5 years, we will have 4.4 billion 5G subscriptions worldwide, accounts for 50% of all mobile connections. And the same positive development can also be observed on the consumer side. The first 5G phone was launched in early 2019. Only 3 years later, in 2022, we have more than 400 5G phones commercially available. You see, looking at all these numbers, you can't help but wonder, what is the actual problem here? It seems that everything's working out just fine. We're making steady progress, aren't we? Well, there are some legitimate concerns under the surface. The 5G spectrum auction in the US is the most expensive one in the history. Over $81 billion was spent for the spectrum, plus more than $13 billion for the relocation and incentive payment. I mean, it's no joke. In total, almost $95 billion was spent even before the deployment. And to make things worse, to build a global 5G infrastructure, $265 billion capex would be required annually over the next 15 years. That would amount to a staggering $4 trillion bill. You see, the expenses wouldn't be such a big problem if the customers were happy with it. After all, the consumers are willing to pay 20 to 30% more for new digital services. But the reality is, the telecom operators already started offering 5G at the same price as 4G. While being satisfied with the speed, 70% of 5G users are complaining about the lack of innovative service and novel application. Compared with 3G, which made mobile internet possible, or 4G, which opened up the world of apps and connectivity, 5G has yet to find its compelling offer. But until then, despite the heavy investment upfront and the massive ongoing expenditure, the telecom providers are likely to keep struggling with putting a juicy price tag on 5G. And now, as promised, we will talk about the ugly stuff. You see, the telecom operators are willing to spend such an insane amount of money because 5G is also associated with tremendous business opportunities. Globally speaking, 5G could create over $13 trillion in sales enablement and over 22 million new jobs by 2035. In the US alone, $1.5 trillion additional GDP could be generated between 2021 and 2025. When ranking market sectors by 5G revenue, industrial IoT is the second largest sector, only behind consumer devices. I mean, to a large degree, it's fair to say 5G is designed with industrial application in mind. From ultra-reliable low-latency communication, massive machine-type communication, to network slicing, the ability to run mission-critical application and private 5G network is less relevant for everyday consumer. Even though we're witnessing many companies across industries running pilot projects, testing different 5G capabilities, and trying out new applications, we certainly haven't seen the real 5G boom yet. We believe part of the reason is really the misconception of industrial IoT. You see, many industrial applications can be powered by 5G technology. Something like smart metering, remote maintenance, track and trace, automation, the list goes on and on. I mean, anything that could be connected to a network has been mentioned by somebody somewhere in the past as one of the potential 5G applications. But here's the thing. Something can be powered by 5G doesn't necessarily mean it needs to be, or must be. 5G is often portrayed as the last missing piece of Industry 4.0, even though many connectivity options are out there that are suitable for a wide range of industrial applications. You see, what's crucial for industrial IoT deployment is the so-called low-power, wide-area network. For many applications, high bandwidth and ultra-low latency are simply not required. Just think about all the sensors installed in the facility, measuring their surrounding and periodically sending back environmental data like temperature, humidity, air quality, etc. Of course, we can have all of them running on 5G network. But do we really need gigabits per second data rate, millisecond network latency for just that? Alternative connectivity technology like machine-type LTE, narrowband IoT, or even LoRa or Sigfox would be a suitable solution. We will create a separate video on connectivity solutions in the near future and share some of our insights into this often neglected area. As for now, we just want to make the point, the backbone of industrial IoT is connectivity. But connectivity is much more than just 5G. These alternative connectivity options have not only the adequate performance matrix, but also extremely low power consumption. For instance, narrowband IoT devices have 10 plus years battery life. And this might be much more advantageous than many people believe. You see, Intel's development center PTK1 in Israel is considered one of the prime examples of smart building. It has more than 14,000 sensors generating 50 terabytes of data every day. If the battery life was only 3 years, almost 5,000 sensors would need battery replacement every year. And I'm really not so sure who wants to be that battery guy. If an application requires high bandwidth and is not battery powered, the recently released Wi-Fi 6 would be a really good option. Wi-Fi 6 and 5G can deliver rather comparable performance in many regards, especially in the case of data rate. Both technologies could deliver up to 10 gigabits per second peak data rate. Although I should also point out that higher data rate of 5G comes at the price of lower penetration power of millimeter wave. You see, higher data rate is only achievable in 5G high band, which is the portion of the spectrum starting with 26 GHz. In an indoor environment, in order to have sufficient coverage, 5G would more than likely use low and mid-band spectrum, which in turn will limit the data transmission. On the other side, Wi-Fi 6 is specifically designed for indoor applications. There is a clear advantage in terms of indoor coverage. The network latency of Wi-Fi 6 could be reduced to less than 10 milliseconds. Admittedly less impressive compared with 5G's 1 millisecond, but it's more than capable of handling demanding applications like comforting VR/AR experience, which would require less than 15 millisecond motion-to-photon latency. In addition, it also meets the requirement for the safe use of AGV and most of the stationary robotic applications. It only falls short in some use cases that are extremely sensitive to latency, like collaborative robots with latency requirement less than 5 milliseconds. You see, with so many alternative options, which more often than not could even provide better price-performance ratio, we have to address one crucial question that has been raised by many. What is the killer app for 5G? Is there anything that could bring meaningful benefit and at the same time only be enabled by 5G? It was quite surreal to hear T-Mobile CEO Mike Sievert calling 5G smartphone the killer app. And I was more than confused when IBM's Chief Technology Officer crowning Boston Dynamics Spot as a killer app. Over the years, many things were once considered the 5G killer app. From augmented reality, virtual reality, to remote surgery, autonomous vehicle, even metaverse. But none of this turned out to be true. We certainly don't pretend to know the answer to this trillion-dollar question. Nevertheless, we do believe the key really lies in the ultra-reliable low-latency communication, which can only be made possible by either fiber optic or 5G. It might sound a little bit cynical, but at least for now, 5G might be a superb technology that's searching for the right problem to solve. At the same time, in a strange way, this is the intention. From 1G to 5G, the paradigm has been largely matrix-driven. The mantra has always been, build the technology, the applications will follow. Until now, every single time, we've found the killer app. I mean, it works until it doesn't. And here is exactly where we are right now, in the middle of the search for the killer app. I hope the first part of this video could be of some help to you. In the second part, we will move our discussion beyond 5G and share some of our thoughts on the 6G concept. Thank you for tuning in and take care.